Welcome back, everyone, to the Deep Dive. Ready to go underground today? We're diving into a topic that might surprise you, Legionella bacteria in groundwater.
Most people think of Legionella outbreaks in hotels or on cruise ships, but this research we're looking at today found it in groundwater.
Right. And it raises some serious questions about public health.
Absolutely.
So the study we're focusing on today, it was published in Water Research.
Yeah, it took
Yeah.
place in the Las Vegas Valley.
And the results are, well, they're pretty eye-opening, to say the least.
They looked at all kinds of water sources, treated water, surface water, but the groundwater wells, that's where things got really interesting.
Okay, so before we dive into all the details, let's make sure everyone's on the same page here.
Sounds good.
What exactly is Legionella, and why should we be worried about it in our water?
Well, Legionella is a type of bacteria, and there are actually many different species.
Okay,
But the one that causes the most trouble is Legionella pneumophila.
that name rings a bell.
It's the one responsible for Legionnaires disease.
Ah, okay. A pretty serious form of pneumonia.
Right. And unfortunately, cases are on the rise.
And you know what's even more alarming? Estimates suggest that the number of Legionnaires disease cases in the U.S. already exceeds the safety threshold used for other waterborne pathogens.
It's a real concern, yeah. And you know what makes this study so important is that most of the research on Legionella has been focused on building plumbing and water systems.
Makes sense.
But this study really puts the spotlight on groundwater, and that's a source we haven't studied as much.
So let's get into the specifics of this Las Vegas Valley study. What did they actually find?
Well, they tested water from 61 groundwater wells,
Okay.
and this was before any disinfection processes.
Okay.
The remarkable thing is they found Legionella pneumophila in every single one.
Wait, you're saying every single well?
Every single one they tested.
Wow, so this isn't just some isolated case.
Not at all. And it wasn't just a few bacteria here and there either. Some of those wells had really high concentrations,
Really?
especially when they were first turned on after periods of inactivity.
That makes sense. Groundwater wells, especially in a place like Las Vegas, they're not constantly running, right? What happens when those wells are reactivated after sitting stagnant for a while?
Yeah, that initial flush of water, that can contain a lot of bacteria.
I see.
They did find that flushing helped reduce the levels, but it didn't completely eliminate the bacteria.
Interesting. So flushing helps, but it's not a cure-all.
Nope. And you know what else? They found a correlation between the length of time a well was inactive and the concentration of Legionella pneumophila.
So the longer a well sits idle, the greater the risk.
Exactly. Some of the wells in the study were inactive for over a year,
Wow.
and those had the highest levels of Legionella.
Now, I know they also looked at how chlorine affects Legionella. I mean, chlorine is commonly used to disinfect water, right?
Yep. Yeah, they did. And they found that chlorine disinfection significantly reduced Legionella pneumophila levels. But here's the catch. To completely eliminate the bacteria, they needed to use higher chlorine doses than what's typically used in the Las Vegas water system.
That makes me wonder if just using more chlorine is the best solution. Are there any downsides to that?
Yeah, that's a great question. You see, higher chlorine doses, they can lead to the formation of what are called disinfection byproducts, and those can have their own health risks.
Oh, so it's sort of a balancing act.
Right. You're trying to kill the bacteria, but you also don't want to create other potentially harmful substances. It's tricky.
So what does all this mean for the average person? Should we be worried about drinking water from the tap?
Well, right now, the U.S. doesn't actually require routine testing of groundwater sources for Legionella.
Oh, wow.
And this study really makes you think that maybe that needs to change.
So while the Las Vegas water utility is taking steps to deal with this, like temporarily shutting down some wells, I mean, could this problem be happening in other areas too?
It's definitely possible, especially in places with similar climates or where wells are operated in a similar way.
It makes you think.
It does, and it really highlights how important well maintenance is. Things like regular flushing, especially after those periods of stagnation, are crucial for minimizing the risk.
So it's not just about treating the water, it's about managing the source itself.
Exactly. Now, there's another really interesting part of this study I want to tell you about. They didn't just look at the bacteria levels, they also investigated other factors that might be linked to higher concentrations of Legionella pneumophila.
Oh, this is where it gets really fascinating. What did they discover? So tell me about these other factors. What did they find?
Okay, so one thing they noticed was that higher levels of Legionella pneumophila were often linked to elevated turbidity in the water.
Turbidity.
Yeah, basically it means how cloudy the water is.
Oh, okay. So the cloudier the water, the more likely it is to have Legionella.
Right, and that makes sense if you think about it. Cloudy water means there's probably more stuff floating around in it.
Like what kind of stuff?
You know, things like organic matter and minerals, which can actually create a really nice environment for bacteria to grow.
So it's like a feast for the bacteria.
Exactly. And what's really cool is that this turbidity thing, it could actually be used as kind of an early warning system.
How so?
Well, if water utilities regularly check the turbidity levels, they might be able to spot a potential Legionella problem before it gets out of hand.
So just by looking at how cloudy the water is, we could get a heads up.
It's possible.
Now, what other correlations did they find?
They also found a link between Legionella pneumophila and something called adenosine triphosphate.
Adenosine tri what now?
Adenosine triphosphate, or ATP for short.
Okay, ATP.
It's basically an energy molecule. It's found in all living things.
Got it.
So higher ATP levels in the water, that means there's more biological activity going on.
Ah, so more life in the water, more potential for Legionella.
Yeah, you could think of it that way. And like turbidity, this ATP thing could also be helpful for monitoring. Water utilities could keep tabs on ATP levels and use that information to get a sense of the potential for Legionella.
So we've got turbidity and we've got ATP levels. What about the depth of the wells? Did they find any connection there?
Yeah, actually they did. Their findings suggest that Legionella pneumophila might be more common deeper down in the wells.
Interesting.
Makes you think, doesn't it? About well design and things like that.
It does. Like maybe there's a certain depth that's best for minimizing Legionella growth.
Right. Or maybe there are specific well designs that could help reduce the risk.
Lots of things to consider there.
For sure.
So we've covered flushing, chlorination, turbidity, ATP levels, and well depth. But there was another approach they look at too, something called in situ disinfection.
Yes, in situ disinfection. That basically means you're treating the well water right there in the well itself.
I see. So how did they do that?
They used a super high concentration of chlorine, way higher than what you'd normally use for disinfection.
Okay.
And they let it sit in the well for about a day.
So a really strong dose of chlorine and a long contact time. Did it work?
Well, initially it seemed super promising. Right after the treatment, the Legionella pneumophila levels dropped dramatically. They were almost undetectable for the first few days.
So, problem solved.
Well, not so fast. While the initial results were great, after about 72 hours, the Legionella started to bounce back.
Oh, no.
Yeah, and within a week, the levels were back to where they were before the treatment.
So it's kind of like a temporary Band-Aid.
Pretty much, and that's what makes this issue so challenging. We need to find solutions that provide long-term control, not just a quick fix.
What about just increasing the chlorine doses in the water system overall? Did they say higher doses were needed to wipe out the bacteria completely?
They did mention that, but remember we talked about the concerns with using higher doses of chlorine.
Right, those disinfection byproducts.
Exactly. It could end up creating other problems down the line.
Okay, so if flushing alone isn't enough, higher chlorine levels are potentially risky, and this in situ disinfection is only temporary, what are we left with? What can we actually do about this problem?
Well, that's where this study really pushes us to think outside the box. It tells us we need to take a multifaceted approach.
What does that mean?
Basically, it means we need to use a bunch of different strategies together. You know, we got to be proactive. We got to monitor the water regularly. We got to use tools like turbidity and ATP monitoring to get ahead of the problem.
Okay, that makes sense.
We also need to improve well design and make sure they're operated in a way that minimizes stagnation and bacterial growth. And of course, research is key. We need to keep searching for new and better ways to treat the water.
You know, it's crazy to think that something so tiny, something we can't even see, could have such a big impact on our water and our health.
I know. This microscopic world is so complex, yet it's connected to everything.
It really makes you appreciate the interconnectedness of nature.
It does. And it underscores why it's so important to protect our water resources.
Absolutely. But before we go too deep down the philosophical rabbit hole, there's one more detail from the study that I found super interesting.
Okay, I'm all ears.
They looked at how chlorine affects not just Legionella, but the entire microbial community in the groundwater. What did they learn from that? They looked at how chlorine affects not just Legionella, but the entire microbial community in the groundwater.
Yeah.
What did they learn from that?
Well, it turns out that while chlorine is good at reducing the overall number of bacteria, it also causes some pretty big changes in the types of bacteria that are present.
So even though it's killing off bacteria, it's also kind of like reshaping that microbial community.
Yeah, exactly. It's like imagine you're cleaning up a room, you get rid of some clutter, but you also end up making space for other things to move in.
So chlorine's getting rid of some bacteria, but it might be making room for other types to take over.
Exactly. And that's where things get really complicated. We can't just focus on the immediate effects of the chlorine. We also have to think about the long-term consequences for the microbial diversity in the water.
I see what you mean. A diverse and balanced microbial community is probably important for a healthy ecosystem, right? Even in groundwater.
It is. And disrupting that balance, well, it could have unintended consequences. For example, if we wipe out certain types of bacteria with chlorine, we might actually be giving other, potentially more resistant species a chance to flourish.
So it's not just about eliminating the Legionella, it's about understanding how our actions, like disinfection, can impact the whole ecosystem beneath the surface.
Right. It's about finding that balance. We want to control the harmful bacteria without harming the good microbes that are also important for a healthy environment.
This is also fascinating. We often take water for granted. We think of it as just H2O. But there's a whole world down there. It's a complex ecosystem with all kinds of microscopic life that we rarely even think about.
Absolutely. And the more we understand those intricate relationships, the better we'll be at managing our water resources and protecting public health.
So where do we go from here? What are the key takeaways from all of this deep dive into the world of Legionella and groundwater?
Well, I think the study is a real wake-up call. It shows us that Legionella can be a serious threat in groundwater, not just in places like hotels and cruise ships.
And it really underscores the importance of staying ahead of the game, being proactive about monitoring, and having good management strategies in place.
Absolutely. We can't just wait for an outbreak to happen. We need to be testing regularly, using those tools we talked about, like turbidity and ATP monitoring, to assess the risk and then take steps to mitigate it.
And research is crucial, right? Finding new and better ways to treat water and explore alternative disinfection methods that are maybe more effective and less disruptive to the whole ecosystem.
Couldn't agree more.
Well, this has been a real eye-opener. It's amazing how something as essential as water can also harbor these hidden dangers.
It is, but, the more we know, the better equipped we are to deal with these challenges.
Well said. A huge thank you to our expert for walking us through this fascinating and timely topic. And to you, our listener, thank you for joining us on this deep dive into the world of Legionella in groundwater.
It's been a pleasure. And remember, stay curious, keep exploring, and we'll catch you on our next deep dive.
Until then, keep diving deep.